Hello everyone. Yeah, I remembered to mute YouTube this time. We're back again, day 16. We seem to have arrived at this little island. Haven't started yet, of course. Same as usual. Let me just adjust this mic a bit. There. Right. Maybe I should ping. Right. So, day 16. Ticket translation. By the way, I was talking with someone on Facebook just before this, so I might keep getting notifications and stuff. If you hear dings in the background. Anyways, day 16, ticket translation. As you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. Wait, this tiny island has a high-speed train? To where? Well, I guess if this is the curvature of the Earth, it's actually a pretty big island. Anyways. However, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Unfortunately, you can't actually read the words on the ticket. Oh, there's another hidden message. What did it say? This actually happened to me once, but I solved it by just asking someone. I have this really annoying, like, translucent hover messages. I should fix that. Yeah, that is one way of solving stuff like this in real life. Just ask someone. You can, however, read the numbers. And so you figure out the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the numbers on your ticket, and the numbers on other nearby tickets for the same train service via the airport security cameras. Of course, much easier to hack into security cameras than just to ask someone. Together into a single document you can reference. So that's my puzzle input. The rules for ticket fields specifies a list of fields that exist somewhere on the ticket, and the valid ranges of values for each field. Okay, for example, a rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class, and can be any value in the ranges 1 to 3 or 5 to 7, inclusive, such that 3 and 5 are both valid in this field, but 4 is not. Okay, each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. Okay, is that actually what the tickets look like in our file? No, okay. Right. So they're comma separated values. And here is our rules. Right. Right. You can identify invalid. Right. It doesn't. Wait, where are we? Here. Yeah, each ticket is represented by a single line of comma separated values. Here, question marks represents text in a language you don't understand. This ticket might be represented as 101, 102. Yeah. Of course, the actual train tickets you're looking at are much more complicated. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field, the second number is always a different specific field, and so on. You just don't know what each position actually means. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. So the one labeled your ticket. We only care about the nearby tickets. Right, and all of these seem to be 2 ranges each with an OR. Interesting. For example, suppose you have the following nodes: classroom seat. I don't know which these are. These are nearby tickets. It doesn't matter which position correspond to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. The values 4 and 55 and 12 are not valid for any field. So 4 isn't valid for this rule. It's less than this and it's less than this. It's not valid for any of these. And same 55, it's just higher than all of them. And 12 is higher than this one, but in the mid-range for this and lower than this one. Adding together all of the invalid values produces your ticket scanning error rate, which is 71 apparently. Consider the validity of nearby tickets you scanned. What is your ticket scanning error rate? Okay. So we seem to have, let's not save that in that folder. Day 16, yeah. So let's have a look at this. We have rules separated like this. We have your ticket part. We have nearby tickets. I'm thinking, which I've seen a lot of people do this, or I've seen suspicious amount of talks about NPEG in the NIM channel today. So I think we might want to parse this just into something nicer looking. So let's start by importing NPEG. So for those of you who don't know, NPEG is this great parsing library for NIM, which uses PEG syntax, or kinda like, or mostly like PEG at least, and it has some. It works in NIM, pure NIM, so you can use it on compile time. You can use it anywhere, and one of the really cool features is that it actually can output railway diagrams of your parser on compile time. I'm going to show that in a minute. And it can also generate these trees as dot files, which is just super cool. Anyways, let us just have the rules here up in case I need those. So we're just going to say raw data is just read our entire input file. And we are going to be making a parser like this. Yeah, that looks good. So we are gonna create this parser. And we are just gonna say, yes, I'm gonna check. I'm gonna check Twitch chat. Well, let A, B, or C, D has to be set up for NIM. I mean, that data type is seamless for this problem. Yeah, the range data type. By the way, parsers have a match file. Oh, PEG has a match file. Then we don't need this. Neat. I really, I mean, I do have my little program. Let's see how that, if it still works as it's supposed to. Okay, so now in theory I should get Twitch messages up on screen as notifications. Hopefully. Which makes them easier to see for me. Yep. Looks good. And you can see them on stream as well. So for the people watching this on YouTube later, it's easier to see them. So we are just gonna say, what's our root parsing rule gonna be? I'm just gonna say, oops. Just gonna say notes, and notes starts with oh, other way around. So let's have a look at this. Notes starts with these rules. So we're just gonna say rules. We are going to store our rules as a sequence, or actually as a tuple of a name, string, and we need 2 ranges. I'm not entirely sure if I can I just store range types like that? Sets. Well, that is true. Yeah, okay. Just have a set of integers, or I guess we need it to be this because the basic sets in them can't be full 64-bit integers because they are bit sets, so they would be huge in that case. Yeah, so rules is just one or more rule, a rule, and of course one or more rule followed by a new line. A rule is a simple simple lowercase with space we have one. Oh, that's in so it just takes sets of characters, but there are some handy ones to find in this module. We have letters. There's no like lowercase. That's annoying. We're just gonna say, I mean, it doesn't really matter. Like, we can look at our input and see that it's not gonna be anything else. So A to Z, we're gonna capture that. We're then gonna say that we're followed by a comma equals. Let me just open up the input here. Yeah, so we have a colon equals, and then we have the first number. So we're gonna capture, and that is a digit, followed by a dash, followed by capture more digits, followed by, and we're actually gonna split that out into rule. So let's call that a, I think we can call that a range, even though, so this is a range. I'm just gonna pop that there. So followed by a range, followed by the word or with spaces around it, and followed by another range. Yeah. Yeah, I guess we should use plus here actually. So plus, same as with regex, plus is one or more characters. star is 0 or more characters. And we want some digits here. Right. So that should match up until this point. And in fact, we should be able to, oh, we need to import stirutils here. It's called digits in here. Is there a separate one here called digit? Oh. Maybe npeg has to find a digit. It also seems to have defined alpha. I mean, it's complaining about something though. Expression blank blank has no type. This of course should be imported properly. Stirutils. Ah, there we go. And you said it has a match file. Aha. Parser and string, and that gives us a match result. Just echo out parser dot match file on input.txt. So this should say something like parsed up until a point. Yeah, okay, true, match length 38. So it matched 38 characters, which is actually a bit less than we would expect. 38 characters seems to be only the first line. But this should match rules, which is a rule, which is this, followed by a new line in brackets, of course. There we go, that parsed 601 characters. I'm using i3. Sorry, I was just replying to him on IRC. Someone was wondering what window manager I was using. Right. So now we've basically matched all the way up to here, including this new line there. So now we are going to say followed by my ticket. And we're going to make a rule for my ticket. Actually followed by a new line and then my ticket. And my ticket consists of the word your ticket and a new line, and then a list of comma separated numbers. So we are going to say a list of digits followed by a comma followed by a last digit. The last digit doesn't have a comma after it, so we can't do that there. We are going to capture these here. So the capture for this will just be a list of all those digits. This should still match. Give us 687. Sounds about right. This is 72 characters. So yeah, sounds about right. And just say that this is followed by a new line. So now we say another new line, and then we say other tickets. And we are going actually to split a ticket. So split this stuff out into its own ticket rule. So we can say other tickets as the words nearby tickets, followed by a new line, followed by a bunch of tickets. And these are all on new lines, and there should be a new line at the end of the file. So this should match a lot of stuff. And then we can say a tuple for rules instead of a table. Well, this rules is this thing, and we aren't, in part 1 at least, we aren't going to look them up by their name. We're just going to be looping through them and checking the ranges. So I mean, there's in part 1 there's not even a point in storing the name. I'm just doing that in case we need it for part 2. If anything, I should make a table from these ranges to a name, but no, wait, then we would have to know the ranges. Yeah, no. I mean, I could store. Yeah, no. The reason is we don't need the table. Could we have used the table? Sure, but there's no point in doing it. Saves us from having to hash those values. So we are going to say that all this stuff should actually be all of this should actually be up there. So our notes consist of rules, followed by a new line, followed by my ticket, followed by a new line, followed by other tickets, which is what we see here. Rules up at the top, then my ticket, then the other tickets. Great, and then followed by nothing more. So 1 matches everything, this is the opposite, so match nothing. So if this gets okay, that means so okay is true. That means the parser has matched. And since we are reading obviously from the beginning of the file until other tickets and then nothing more, we know that we have parsed, in fact, the entire file. So now, and this is sort of the cool part of NPEG. Now we can start. So I threw in these things, which are captures. So now we can start using captures and building up our data structure within our parser. But before we do that, I want to show off this railway diagram stuff I was talking about. Where is that? Captures, string captures, blah 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 blah. What about grammars, composing grammars? I just don't remember what the switch for that is. Here, NPEG graph. There we go. Sorry if I was scrolling a bit faster. I was just wasn't meant for you to be reading any of it. Yeah, so this, how cool is this? I mean, isn't this amazing? And this is all just automatically generated. I don't have to build this myself. Here it just makes it super easy to see, like, and I've done this. I've written these parsers, and I've looked at this output and gone like, oh, okay, so a rule, yeah, that has to be a rule followed by a new line, followed by another rule. So in fact, the rules can be no rules. That's a bug. Rules shouldn't be. We should have at least one rule. So there, just like that, I spotted that we could have no rules. That's not what we want. I mean, in this case, it doesn't matter, but it's just so cool. I really like this. Same here, actually. We can have a nameless rule, which we don't really want. But yeah, those doesn't really matter. I just think this is really cool. Anyways. So yeah, now we need to parse this into structures. So we have this rules thing. This of course needs to be a sequence of these. And now this is where using this is kind of finicky. Because as you can see, for example, in the rule thing, here I capture, so again, means capture. I capture the name, but I don't capture these ranges, because then I would have to parse those ranges within this rule again. So I capture these numbers down here, right? The problem with that is that I need to do something with them here. And that's one thing I don't really like with npeg, is that I can't have this range, even though it's a different rule. I can't get the sequence of captures in here. That would have been really neat. So what we're actually going to do here is just here we add a rule to the end, which just has an empty name. Invalid needs to be the set. So here we need to create parse int of. All right, we have two. So if the last rule has a name, create this one, and this is like this, I think. Captures. String captures. $1. Thanks. Yeah. $1 parse int $2. Otherwise, so if it doesn't have a name, we know that it was created like this, and then we can say that rules yeah, I could. Wait, what? There are exactly two ranges. You could put them in the same line as the rule 4 times. Yeah, I could. I mean, I could just manually expand this. Yeah. It's not pretty. And I've used npeg for other stuff. I've used npeg for other stuff where that sort of wasn't possible, but I still want to be able, like, it would be nice to just be able to get the list of captures here. Better yet, of course, if this could return a tuple, for example, and I could get that here. But I mean, that will be harder to implement, but that would be super cool. Oh, wait, don't spoil part 2 for me. Sev, if you're watching, by the way, feature request. I should make a GitHub issue for that. Anyways, so we are going to say that rules, the top rule set of valid stuff should include this new set. So just generate a new set here. And it's not called include when we add a new set. It's called, what would that be? That would be the, no, that's this set. Sets. Oh, I had it there. Yeah, I guess it's union, yeah. It's just called, it's just plus. Can I do plus equals on a set? I guess Nim just rewrites that too. Whoa. Oh, and these of course needs to be turned into uint16s. Nah, I think this should work. Nope, apparently not. Rules. Just do that. Yeah, so now basically what this does is that it creates an empty rule at the end of the rules sequence. And now we're gonna add a name to this. So we are going to say that rules at the top of the list dot name is equal to this capture. So here we only capture the name, and we're just setting the name here. And setting the name here means that when we go down here, we can see that the name is larger than 1, so we need to make a new one. Otherwise, we would just keep adding to the same one over and over and over. Now, this is fine for this, but just as like if you're using npeg for something else, you might want to keep this in mind. If this matches, like if we came here and if we had some conditional and it had parsed range and it had done this and then figured out in that branch, figured out that, oh no, it doesn't say or afterwards, and then rolled back and then tried something else, this would still have happened. So your rules here would then have that thing already attached to it. And this is why I kind of want to be able to get these captures here, because you need to be a bit wary of that. Anyways, that should be our rules all parsed, so we can now just echo out our rules. Yeah, prints out this nice graph for us. Container is empty. So of course, if rules.length is 0, we should also add a new one and not try to read the last one. Here we go. Right, it prints out sets really verbosely. Good to know. I was confused there for a second. I thought we had messed something up. Yeah, departure location. Yeah. And then valid. I'm just gonna assume that is correct. I'm not gonna check. Yeah, so there we have our rules. That's good. Let's check, or let's next store my ticket. My ticket is a sequence of integers. So here we don't capture anything. We say that here we capture a ticket. So here we are actually going to make a current ticket object. And in here, we are going to say that my ticket is equal to the current ticket. And here we are going to work on the current ticket object. The current ticket is equal to, it's just called captures, isn't it? So the thing I was doing before, the $1, that just gives you no, inside of a role. Captures. Code block captures. Here we go. Capture. Yeah, so you can either get them like with a $1 syntax, or we can access this capture thing directly. And of course, it's this object. So it's going to be .s to get the string out. So we are going to grab, but the first one. So note that that $1 was our first one. Capture 0 is always the entire thing that we matched against. So what we're gonna say here is capture from 1 all the way to the end. So that's all of the numbers. And then we are going to map that with Parsing. And for that we need secutils. Right. Oh, and we are going to just map it and say it.s.parsing. So we actually map the string there. So now we should be able to grab my ticket out of this. And also cur ticket should now be the last ticket in our set here. So this should be our ticket. It starts with 191, ends with 179. 191 ends with 179. That's good. And the last of these ones, 772.256. 772.256. That looks good. So now in this other tickets here, we just need to say that tickets, which I haven't created yet, .add the current ticket. And tickets is just going to be a sequence of ints. There we go. So now if you do for ticket in tickets, echo ticket, now we should just get all of our tickets. Oh, we only got the last one. Right. We do that as we loop for the ticket rule there. We are just going to create a dummy rule here and do this down there and match match this to other ticket like so. Remove that. There we go. And this should not contain, this does not contain our ticket. 482.615 should be the first one here. 482.615, yep, good. Basically what I did here, I created this other ticket that just matches a ticket, only to be able to attach a custom rule to when a ticket is matched from within this other ticket's rule. So we can match once per ticket. But I don't want to put it in this one because that would interfere with my ticket. What I could have done is to do this and say tickets.add, remove this, have the ticket, and then create a special rule here, and just empty out the tickets. This will also work, and give us the same result for it to 615. And if we just echo out I mean, it depends. Yeah, that's my ticket. So that really just depends on how you want to do it. Basically what I'm doing here is I'm adding them all to the tickets, but when I'm parsing my ticket, I'm actually just yanking it out of that list, and then just resetting the list to have 0 elements. I guess, is there a pop for sequences? I think there might be. Yeah, so we can actually do it like that instead, because we know it's only going to be 1 in there. Anyways, back to the actual task at hand. Now we have parsed all of our stuff into a nice, convenient structure. So in this example, the values on the nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. Yeah, so we want to go through all of our tickets, check if it's in any of the ranges. If it is, it's good. We don't care about it. If the number is not in any of the ranges, we are going to sum up those numbers and echo them out. So, oh, is my volume low? I can increase it if you want. Let's see. Is it better now? Oh. Sorry to everyone who had their volume set fine or high, if I'm now super loud. A bit better. Anyways, so for let's keep a sum. What did they call this? My ticket scanning error rate. So error rate is 0 for ticket in tickets. We don't care about my ticket for now. So for ticket in tickets, for number in ticket, and then for rule in rules. So a nice little triple loop here. If number is well, it shouldn't be in any of the rules. You know what? So we can skip this. Let's create a super rule, which is a set of UN16, and then go for rule in rules. Super rule is super rule plus the rule valid set. So the union of basically the union of all the rules. If number not in the super rule, so if this is an invalid number, then error rate plus equals this number. And we don't actually care about, it doesn't say, it doesn't really specify what will happen if we have multiple, but I'm guessing we're supposed to count all of them. Yeah, so this should work, right? Go through all the tickets, grab all the numbers of the tickets for all the numbers that are not in the super rule. So the rule, like the set of all values that are valid. If it's not in there, count it in our error rate. And Bob's your uncle. The error rate. Oop. Oh. Well, that's not right, like that. I never checked actually. Yeah, no, okay. None of these seem to be actually be higher than a UN16. That would have meant we would have to rewrite some stuff here. There we go. An error rate might grow higher though. So let's keep that as an integer. And let us try this. I mean, this is getting into a pretty long episode simply because you wrote that parser in the beginning. And I have stuff to do today, as with all other days. I'm actually going to fix my fireplace afterwards. After much back and forth with the fire department and like the guy who originally made the fireplace and a bunch of hullabaloo. Ooh, that's actually not correct. Interesting. So yeah, after a lot of back and forth between all of the different people and instances and whatever, they figured out that no, yeah, your fireplace is fine. You don't have to worry about it. Like, oh, for fuck's sakes. Oh. Hey, new milestone. 2 spammers in one stream. Well, isn't that fun? How do I delete, ban these people? I can reply to them. That's not what I want to do. Ah, here. No, I don't want to add them as a friend. I want to ban them. And same with this guy. Ban that guy. Nice. Okay. If you could try saying something now. I think they might have broken the IRC thing with all their special characters. Yeah, so this seems to just basically list all of the numbers, right? Ah, no, it's not all of them. But there are more of them than there should be. So echo out the super rule. And this is going to be that horrible output of a range again. 1, 2, 3, 5. Wait, what is the test inputs? Rules. Yeah. So 1, 2, 3, fine. 5, 6, 7, sure. And then 8. Yeah, so 6 through 11 is in there. 13, so we don't have 12, but we have 13 all the way up to 40. And then from this rule, we go all the way to 44. Oh. Why haven't this taken us to 44? And why haven't this taken us to 50? Interesting. So that is both, aha. There. So I was parsing the same number twice. There we go, 71. That's the right number. Okay. So simple little error there. 71, yeah. And where's that other echo from? It still echoes out a bunch of numbers. Oh, it's from here. We don't want that when we're running on the full set of data. So let's run this on my actual input data. And let's see what we get. 26053. Hurrah! That's our answer. Very well. No one has tried talking to me on YouTube today. That's good. Well, I mean, it's not good that people don't want to talk to me. It's just good because I haven't checked it up until now. Anyways. Now that you've identified which tickets contain invalid values, discard those tickets entirely. I was afraid of that. Use the remaining valid tickets to determine which field is which. So at this point, we are going to copy my part 1 over to a part 2. Nope. And we're going to open that up. Oh, come on. This fuzzy matcher should really have a special rule for the folder I'm in. Right. Using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If seat is the third field, it is the third field on every ticket, including your ticket, which I guess is the important part. For example, suppose you have the following notes. Based on the nearby tickets in the above example, the first position must be row. Because row, this matches with all of these or this matches with the 2 first, and this matches with this one. And I'm guessing none of the other sets match with this. And you can conclude that in your ticket class is third position, second position must be class, third position must be seat. And I conclude that my ticket class is 12, row is 11, and seat is 13. Once you work out which field is which, look for the 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? Okay. So, for part 2, we don't really care about the error rate. For the error rate, we are simply going to add a block here called check ticket. And we are going to break out of the check ticket block. So if a number is not valid, then we just skip the whole ticket. Actually, we want to loop over. We want to loop over numbers. Well, I mean, this is a pretty cheap test, isn't it? No, but that would mean double looping. So basically what what we want to do for the second half, let me open this. That bright white is kind of annoying. So basically what I want to do is to step through sort of like row by row and checking which field or which rule is valid for each of the columns. But to do that, I need to find those that are invalid and just remove them from the set. So I guess we want to remove those. I'm thinking we can't just remove them from the sequence, but removing stuff from the sequence while looping over the sequence isn't a especially good idea. You know what we can do? We just create a new valid tickets set. And for each, if we have looped through all the numbers on the tickets without breaking out of the check ticket, then we know this is a valid ticket. And we can just add the ticket to there. So now we just have a set of valid tickets. So for I in 0 ... well, let's just grab my ticket dot high. So the highest index in my ticket. So basically loop through all the numbers. And then for ticket in valid tickets, we check the number in that ticket. And basically we want to figure out which of the rules match for which of the fields. So we can create a we can create a mapping here, which is sequence of strings. And in this case, it would make sense for this to be a table. So in fact, I'm going to make my rules here a table, just from string to a set. I'm just going to do that. Have the tables module. And rules. But then we can't do this. I guess if that is true, or if rule, or not rules dot haskey empty string, then rules empty string is equal to this set. Otherwise, then rule empty string dot valid is equal to rule empty string valid there. And then we are going to say that rule $$1 is equal to rules empty string and rules dot delete empty string. There. And for the values of the rules, so that will be the values of the rules will just be all of these sets. And now we're just looping over all of the sets and just adding them directly like that. Oh, and this is of course not dot valid anymore. Which probably maybe means I can fit this on a single line. I can. Nice. This is of course a plural. There we go. Okay. So now basically we have a sequence of fields, which is going to be, we're going to be adding the keys here as we find which key they match. So for each ticket in all of the valid tickets, we are going to be looking at the ticket number. But we need to have some kind of data structure where we have all of the options for a given field. Let's create a sequence of strings. Actually, this can be a, what is that? Executals. We have the new sec width, which is length and untyped, like that. New sec width. We are gonna create this as long as my ticket dot length, and the rule for all of this is gonna be 2sec rules dot keys. So this is the same 2sec we've been using before. Turns an iterator into a sequence, and we're gonna iterate over all the keys, and we're gonna create this sequence. So basically this creates a bunch of sequences, all with all of the keys that are valid. And now we're gonna look through this. I'm gonna create a block here. Well, we can do that later. For ticket invalid tickets, and then for rule in fields I, so this is going to be a string. This is a string of the so far not invalidated rules. So if the ticket and let me just say that possible rules is this. For rule in, well, actually, rules remove is a sequence of string. If ticket.I is not in the rule that is named in the possible rules field, then we know we can remove that rule. And then for rule and rules to remove, fields I dot remove, is that by index or it's called delete? Yeah. Yes, that is a, actually takes two. Is there one that, oh, we could actually do a keep if on a var sequence with a predicate. That is a better way of doing this. Yeah, instead of that, do fields.I keep if what was that? Keep if, is that available as a, it's available as a template. Just so that I don't have to create an actual procedure, because that's kind of awkward. I could import the sugars module, but so keep it if do. So if this should return a, yeah, it should just return a Boolean. So keep it if ticket is in yeah. So for all of the possible rules that or the possible fields that this can be, keep the field if the value of the column in the current ticket we're looking at is in the rules for that ticket. Or for that field. Now we can echo out our fields, and we should now be left with only one rule. Oh, we actually have multiple. Either we did something wrong, or is this the same? No, it's not the same. So let's create a new file here called test input 2. I'm just gonna add this into that file, and for part 2 we are gonna say that we parse test input 2. See what it spits out for us now. It's row class and row class seat. Right. Oh, row class and row class seat. So we need to do some extra filtering, because this first one can only be a row. This first one can only be a row. That means that obviously for this one, this can only be a class. And since row and class are taken by these, then this can only be a seat. So we need to filter out the singles from this list and filter those out of the other ones. Right. So let's create a sequence of strings for all the singles, and then for field and fields, if field right. This should really be called, let me rename this to possible fields. So for fields and the possible fields, if fields.length equal 1, then singles.add the only field from there. Echo out just the singles just to check that we get something out of here. We get row. So now we need to go through all of the fields and remove row, then calculate the singles again, then do that until they're all singles. Let's do that. While singles.length is not equal to singles.length is not equal to my ticket.length. So as long as we haven't done all of the fields yet, add field to the singles, and then the possible fields fields and possible fields. So we can do that here. Items fields dot keep it if fields dot length is 1 or oh no, wait, that's not what we want to do. We want to loop over for field. Oh no, wait. Yeah, that is what we want to do. So for the list of possible fields, you want to keep it if it's 1. Yeah, if fields is 1, we want to keep the only one. Actually, we can do if fields length is not equal to 1, then filter out the fields if it is in singles, right? So if the list of fields and the possible fields and items is just to have fields be mutable, which we need for keep it if. If I remove this, then that keep it if call should throw an error saying that we try to change fields, which we aren't allowed to do, but with items we are allowed to change it. So yeah, if for all of the fields in the list of possible fields, if the length of fields is equal to 1, then we'd say, this is a single value. We know where this belongs. Put it in here. We should only do that if this field is not already in singles. Be not in instead. There. So if the fields is not in the singles, because we use the length of singles as our loop variable here, so we need to make sure we're not adding duplicates into here. So if the fields, if the only thing in the fields, because it's length 1, so if the only one is not in singles, we add it to the singles. Otherwise, we loop through all the fields in this list of possible fields and remove and keep it if it is not in the list of singles. So now at this point, singles should be equal to my tickets. So we have gone through all of them, made sure all of them are singles. And now, finally, our possible fields should now be all one long. Row, class, seat. They're all just one possible field for each of the fields. Let's run that with my input. Yeah. So we have train, type, departure time, seat, departure platform, and blah, blah, blah. All of these are nice and have a single possible field for them. And back to what our task was. Once you work out which field is which, look for the 6 fields on your ticket that starts with the word departure. What do you get if you multiply those 6 values together? So I'm gonna set my sum to 1, and I'm gonna go over the fields in my possible fields. Now I know all of these have just one field in them. And I'm gonna say if fields 0, so the only thing in it, starts with the word departure, then we are going to time equal the sum. So for the first one, times by 1, it's going to be just set to this, by the look for the 6 fields on your ticket that starts. What do you get if you multiply those 6 values together? Oh, right, on my ticket. Right. So we need an index here, sum together my ticket and this index. And of course, we're gonna need to use that sum. And this is an integer, or we're gonna make it an integer to make sure that this sum variable is large enough. There we go. This should be our answer. Hurrah! Yeah. So that was day 16. Bit trickier than the previous days, or at least it took us. Well, it only took me an hour and 20 minutes, so not too bad. But we wrote this parser. Took a little while. And then this sorting logic was kind of like bit back and forth, bit of logic there. Probably some pitfalls. Probably some ways there to mess up. But yeah, that was day 16. I'm just staying around now if anyone has anything to come with, any comments or add day 16. Just gonna push this to GitHub real quick. By the way, that program that just pops up briefly, where I type in my password and then choose my entry. That is my password manager. Our solutions were really similar. I just failed on the rule order part. The rule order. Wait, how did you mess up the rule order? Oh, which rule is which? Yeah. Yeah, I mean, that was the tricky part of part 2. Just filtering out the valid tickets. I mean, that's basically what you did in part 1. But yeah, this was sort of, I don't know, first thing that came to mind for me. Just start with all of the fields and then just slowly whittle out those that can't work. Yeah, it was a bit annoying. It was like, why? Oh, right, yeah. So those messages didn't show up. And then if it was a field range ID, add that to the order and then move that field. Field was in a field range. Oh, right. Ah, yeah. Yeah, that's sort of what I was thinking of doing, but then I went with this instead, and I'm glad that I did, because basically what you're missing, I think, is this part. Uh, because a field can be valid for multiple, but when you take out all of the singles, then it can only be for one. Yeah. So basically, what I'm doing here, I'm just saying, start with all of them. Start with all the rules. And I mean, this could be cleaned up. We can make this sequence like not loop through and create this sequence for every one of them, but they're not that many, so it's not that slow. But yeah, so just loop through and only keep the fields if it matches. So if it doesn't match one of them, just remove it, and then we need to figure out which fields can only exist in one of the tickets. Yeah. But yeah, that's what all of this logic is for. It's just like loop through until I only have singles, until all of the fields can only be in one possible position, and that's basically what this logic does. But yeah, that was day 16. Going back here. We're now heading back out to sea. Wait, so we were taking... Right. So we flew from here to there. Then I guess we took a high-speed train sort of to another airport. And now we're heading out by plane again. Yeah, I have to head out as well. Eat some dinner and put some water on the fireplace so I can hopefully have a fire here. But yeah, thanks for the comment. Thanks for watching, and I'll hopefully be back again tomorrow with another stream. So until then, have a nice Advent, and have fun.